Okay, I think we'll make a start. Good morning, everybody. And welcome to our webinar today. Today we're going to talk about using breach and attack simulation with the MITRE ATT&CK framework in order to highlight threat actor behaviors within your environment. A little bit about ourselves. My name is Ronan Lavelle, and I'm joined today by my colleague Andrew Brown, and we are from a UK-based but globally operating company called ATTCK, and we are specialists in automating offensive security testing and also in cyber risk management. We provide both services and technical solutions as well. A little bit of housekeeping. This webinar is being recorded today, and a link to the recording will be emailed to all participants within 24 hours. Although your lines are muted, we do very much welcome any questions, and we hope that today's topic will invoke some thoughts and questions for you. So please do use the Q&A function at the bottom of your screen. We do invite you, if you have a thought, write the question there. We will see them, and we will pick them up at the end if that's all right. Okay, so I'm going to hand over my audio to my colleague Andrew Brown, who's going to take you through the introduction to this topic, and I'll check back with you a little bit later on. Andrew.
Ronan, thank you. So some things, we get to talk to a lot of different people in different organizations right the way around the world, and we thought we'd spend a bit of time today having a chat about the MITRE ATT&CK framework and what you can do with it. Specifically, how do we highlight threat actor behaviors, and also how would you use this in a breach and attack simulation scenario. So that's the objective of what we're going to look at today. I'm going to start off by having a look at some relevant information that I've covered in one or two other webinars previously, but what we need to have a look at is some relevant cyber frameworks. And I'd like to go through NIST. NIST is probably the easiest of them out there, and I really like it because it's got 5 words that I need to remember, starting off with identify. And you can apply this or this framework selectively. It doesn't have to be a big bang approach to your whole organization, and we like talking about crown jewels. So if I identify a crown jewel, what would that be? Well, it could very much be a domain controller, or my domain is a crown jewel. If I compromise a domain in my environment, then someone has access to my whole environment. So another crown jewel could be a business application, it could be my endpoint, it could be endpoints in different areas or locations in my organization, like finance, HR, call center. So there's no fixed definition of a crown jewel, but we want to start off identifying them. Then what we're going to be looking at today as we move through this is protect. Does my security control or tool that I have, does it protect? And how do we measure that when we start using a common language to discuss things like MITRE? Am I seeing the detection? Did I detect what went on, even if I might not have, my protection might not have worked, or I might not have needed protection there, or chosen to turn it off? And do I actually have a response, or did I respond, or did my SOC respond? So we're interested in being able to test those and get a greater understanding of that. And then obviously there's recover right at the end. So MITRE ATT&CK put together a framework, and ATTACK stands for Adversarial Tactics, Techniques, and Common Knowledge. This is really a language to be able to have a discussion about cyber threats and cyber threat groups out there and understand their behavioral patterns across the actual environment or your organization. So let's have a look and move on to the actual kill chain. And what do we mean by the kill chain? Well, these tactics and techniques are used not necessarily in order, but they describe behavior of, say, a piece of ransomware or of a threat group. To put this in perspective, let's look at someone who, we probably all be familiar with from movies and watching various movies or reading books, and that is someone who is able to crack a safe. So he gets out a stethoscope and he puts the ends in his ears and he listens for the tumblers and he turns the dial, okay, and you can hear the tumblers all lining up inside the safe, and when they're all perfectly aligned, he's able to open the safe. Now, he's an absolute expert in that area. And if we look at the behavioral pattern there, he understands how all that works. If I were to change the lock on the safe for a digital lock, okay, I have disrupted a behavior pattern. I've actually managed to break the kill chain over here and I have stopped the attack. And very similarly, that can be applied to cyber and cyber threat actors. And that's really what the MITRE attack framework does for you. It describes different behaviors and they don't have to be executed all in order from left to right. So we have something called the Attack Navigator. I'll show you more of a demonstration of Attack Navigator and how that can be used to map different attacks or threat groups or things like ransomware. I've put some URLs down here as to how you can get to the present Navigator, and we will be sharing this presentation with you afterwards. And there's also a newer version out which gives you subcategories, which I will drill down into a bit later as well. So just a couple of other points on the behavior side of things as to things that we will be discussing. Right at the bottom, when we look at something like the pyramid of pain from David Bianco, we have at the bottom things like hash values and IP addresses. Now, when we start talking about hash values, those could be indicators of compromise. I'll show you a hash value and what we could do with a hash value. If we look at IP addresses and where threats are coming from IP-wise, we could block that, but they could very easily pop up from somewhere else. If I go back to our example of, the safecracker and changing the type of lock and altering the behavioral pattern, that's a lot tougher challenge out there and really requires the threat group to go and get or add to their actual group another expert in that sort of section, whereby they now need a digital expert to be able to tackle the locks on the safe. And this is how these teams are built up. And it's much better to look at this from a TTP's perspective rather than sort of hash values, IPs, and stuff like that. Although they are still very relevant in the conversation that we're going to be having. So a couple of use cases that we want to be looking at. Things that we will be discussing is things like adversary emulation. I've mentioned that. What we really mean by an adversary? Well, there are various groups up there that range from nation state sponsored actors to actual groups of cyber criminals out there. And like I said, they have various behavioral patterns, and you need to be able to understand if your industry or they happen to be quite prevalent at the moment, what that is going to do and how your organization would respond to that type of adversary taking on your organization. And you can use that information and be able to set up red teaming exercises. Red teaming is where you get a group of people and it's about testing your security controls everywhere from your protection all the way to your security operations center to understand. And you can use MITRE ATT&CK, either the threat groups or the tactics, techniques, and procedures to put together or build a red teaming exercise. I'll be demonstrating some of that information. We can look at defense gap assessment, either on a specific security control, on various security tools that we might be looking at purchasing, or across a whole organization. We can also look at our SOC if we have one or might be outsourced. How mature is it? Where is it today? What are they detecting? What are they responding to? It's always sort of like, a bit of a head scratching moment. How do I set up my SOC? What should I be doing? Well, one of the ways possibly to look at setting up your SOC and the playbooks and everything within your SOC is around all of the MITRE techniques that you might happen to have. And then we have cyber threat intelligence, which comes in various formats, but I'll be showing you sort of one type of cyber threat intelligence that we could have today around a piece of ransomware that's described using tactics and techniques. And it enables us to have a common language where everybody can share and understand what we're talking about. So what we're going to start off with is, we're going to move on to next, is a quick poll. And that quick poll happens to be, how familiar are you with MITRE ATT&CK? Ronan's got a couple of words he'd like to say about our poll first there.
Thanks, everyone. Thank you, Andrew. So, by the way, I'm very impressed with your knowledge on how to break into safes. I want to quickly point out we don't offer safe cracking services. We would, however, we're going to move into this part of the presentation. We're going to talk about how we can apply the MITRE ATT&CK knowledge base and the TTPs and safely simulate either all of those or specific use cases within a controlled environment. So we're going to talk about simulation. This whole area is relatively new to many people. So we would just like to understand how familiar this area is for you, just so that we can pitch the message appropriately for this audience. And if you have never heard about it, that's completely fine as well. We're going to talk about this from all audience participation. I'll give you a few more seconds on that.
The poll is totally anonymous, by the way.
It is, thank you, Andrew. So I'll end the poll there, thank you. So, no, it's still dynamically changing. So basically, I think the quick summary is that most people are somewhat familiar with this or very familiar, and others have a fairly limited knowledge. And that's helpful and useful for us to pitch this message in this presentation today. So Andrew, do you want to progress further, if you don't mind?
Yeah, so seeing as we're going to be talking about breach and attack simulation, I thought, with a couple of definitions so everybody's on the same page and you understand what we're talking about that. So if we look at it, Gartner defines breach and attack simulation technologies as tools that allow enterprises to continually and consistently simulate the full attack cycle, including insider threats, lateral movement, and data exfiltration against enterprise infrastructure using software agents, virtual machines, and other machines. Now, there are loads of open source tools out there that sit and you can do this with, but not in a very automated fashion. We will point you in the direction, but if you want to try and run this continuously across your environment, you're going to end up having to move towards a more commercial tool. So that's breach and attack simulation. If I look at cyber threat intelligence and what that is and what we're meaning when we talk about it today, it's defined as the process of analyzing information about adversaries as well as the output of that analysis in a way that can be applied to help network defenders and decision makers. And that came from the MITRE organization, the MITRE Corporation. It's a US nonprofit, and they have put together this whole framework. You might be familiar with things like CVEs and stuff like that. CVEs all come from the MITRE Corporation as well. So some threat intelligence, just a simple example of some threat intelligence. Maize Ransomware has been in the news quite recently from the perspective of a major outsourcing company having had their environment compromised by Maize Ransomware. So the example here as to if we were to look at this in terms of MITRE tactics and techniques, we have things like command and control servers, we have defense invasion, we have initial access, and then we have the different techniques that happen to be used and associated with that. And those happen to be, you know, things like spearfishing. So that's one of the ways it went and, got into an organization. We look at command and control servers. It wants to talk back to a command and control server, tell it where it happens to be. There happens to be some file deletion that happens to be going on. So different phases that we want to be able to look at and to be able to test and understand within our organization. And you'll see that there's various attack phases that we might want to do or look at while this is happening. While the ransomware is really in all probability going to do the most damage at host level, we want to understand is it able to infiltrate? So there's various ways it can infiltrate our organization. It can infiltrate it via email. It could move laterally through our organization via email. It could also infiltrate our organization via HTTP, HTTPS. So is that possible? What have we got in place that's going to be able to stop that? And once it gets onto our host, how effective is our host at protecting our environment? And then if we look at it whereby we look at command and control, what do we have in place to prevent the communication with command and control servers? So very simply, we've been able to use the MITRE framework to be able to describe the ransomware, and we can communicate this to all. So in our simulation, we set up a couple of simulators to be able to do this. We have an external virtual hacker. We have a control console, either cloud-based or it can be on-prem. And we happen to have some simulators, which are the little guys with the sort of 9 white dots with a little red target in the middle. And we've put a host simulator on an internal machine, and that could be in various segmented areas of our network. And we also happen to have on various servers in our organization put some simulators as well. They could also be network-based simulators in that actual specific segment. So you have some choices as to how this works. In the next example, what we're going to talk about is how does the simulation work? Well, two ways. What we're interested in is, can one simulator communicate to another? So when we talk about infiltration, if I take my virtual ethical hacker, he's going to try and send an email with the attachments that we happen to have in the malware, de-weaponized of course, to internally to our simulator sitting on our Windows 10 machine or our Mac internal to our actual network. Then the other thing that that internal simulator could do is try communicating through our actual web gateway with our virtual ethical hacker outside on the various ports that would be used to be able to talk to a command and control server and understand whether that happens to be possible. You could also get the malware to move laterally between two simulators internally to your organization via your actual mail system. Those are just the basics of how it works. And what we're interested in is which bits of protection work. So did our web gateway work? Did our mail gateway work? Did we get notifications even if we didn't block it? Did we actually identify or detect it? Did that end up in our SOC? And how did our SOC actually react to this exercise? So we've now moved on to, or got to the area of demonstration. So if you wouldn't mind stop sharing, Ronan, I can just take over and share my screen quickly. So to begin with, we'll give you all these links as well. There's a post that on our LinkedIn page today, if you have a look around, and it's about an evaluation that MITRE did around APT29. Again, I can show you, and I will show you during the course of the demonstration, how we look at the different tactics and techniques associated with APT29. But APT29 is a threat group that has been attributed to the Russian government and has operated since 2008. There's some more notes around here as to what they go and do, but it also gives you a complete scenario overview. And here is 21 participants over on the right-hand side who submitted their solutions for evaluation to MITRE. And you will see MITRE's put together a whole article about it. And we will stress here, no one's interested really about declaring a winner here. This is really a whole exercise on how you would look at testing an endpoint, and that's why I'm sharing it with you today, and various tools that you might use to do that. Within this MITRE article, you will find that they suggest some open source tools and how you can actually perform this evaluation for yourself. They also have some very nice links to, the operational flow as to how this goes about doing it and how you perform these tests. And the reason we're suggesting this and pointing out why we think this is vitally important, this is a design and testing phase. It's a standard engineering principle that you would go through to build a building, build a bridge, and it should be a standard principle that you go through when you design and build any cyber solution for, or architect any solution for your environment. You need to be understand, is it all working once I fit this all together? Because there's many different building blocks from many different vendors. Moving on, we happen to have this whole MITRE ATT&CK framework, and things that happen to be in here now that we've got an expanded version of it. It breaks things down, phishing down into sub-techniques. So like a spearfishing attachment versus a spearfishing link versus spearfishing as a service. Who knew that one day we'd be able to purchase spearfishing as a service rather than sort of, just CRM as a service or something like that. You can actually go out now and purchase spearfishing as a service. It goes through all of these different techniques. You can click through them, drill down, find out exactly what it happens to be if you don't quite understand what they're talking about. And I must admit, with some of them, it's very useful to be able to drill down and find out this information underneath. I'm now going to move into our breach and attack simulation platform. It's a platform called Safe Breach, and this is a demonstration environment. Please, just like under the MITRE page or tab, we said we are not expressing any view about any vendor when we actually test. You'll see vendors' names pop up here. This is absolutely no reflection of those vendors or how well their solution performs. This is a pure demonstration environment to be able to get results out of it, to be able to show people. So we've got our external attacker here. We've dropped simulators in various areas around our demo environment, like on a customer database. We also have a simulator in our corporate user environment and also our production database. And that's actually our environment or our test for where we're at today. What we're going to go and have a look at is two things to start off with, moving into our playbook area of the solution. And what I can do in our playbook area is I can do things like pull up Maize and have a look for Maize Ransomware. Now you'll notice what I now happen to have here is I happen to have all of the associated tactics and techniques with the actual Maize ransomware. The moment I'm just showing the tactics, I can add the techniques as well. I'm not really interested in the modified date or the attack ID right at this moment in time. So we now have this list of what these are actually going to do. And I can see that we're going to have some host level stuff. We're going to move laterally via email. We're going to be able to infiltrate via email. We've got some pre-execution stuff, and we also happen to have some dropping of malware. Now notice they've got some numbers against them. What do those numbers mean? What those numbers mean is if I drill down into this, it's going to test various ways of being able to do this. So we talk about 12 different breach methods. So it's going to try out HTTP, HTTPS. It's going to switch port numbers here as well. So it's going to try a whole pile of combinations here within the system to be able to infiltrate your organization. When we look at dropping the stuff or writing the stuff to disk, we are talking about taking a de-weaponized version of the actual malware. And in this case, it happens to be a DLL, and it's going to write that DLL down to disk into a temporary folder, and it's going to do that for a period of 10 seconds. And I'll show you that we can test that that's actually the DLL within the environment, and it's real proper malware that we're using, except it's been de-weaponized, so it's not going to create any harm. So I can select it very much like that by clicking on here. I can turn around and say what I'd like to do is I'd like to run it on all simulators. This is going to be very much like a cooking show, whereby we'll come back to that shortly. So I've already put the stuff that I need in the oven, and it's cooking away. I can also look at APT29, because APT29 is also something that we've been discussing. APT29, I can do something similar with here, and I can also quite easily pull up all of the techniques and tactics associated with APT29. Let me take the Maize bit out of my filter up there, and there I happen to have all of that. I can do a similar exercise there and be able to run this all on all simulators. Alternatively, I could be running all of the attacks I happen to have in my environment, and it creates very little overhead on my system across my network on a continuous basis to understand what's happening. So let's move now into the results section of this. And moving into the results section, let's have a look purely around a test that I ran. Here's the Maize test that I ran. Let's pull some information around this actual Maize ransomware, and I can see that 5% of the actual simulations weren't blocked. Let me drill down on that some more. Ignore who wasn't doing the blocking here. That's not entirely relevant as to where I want to go. What I get down the bottom at this moment in time, this is my whole organization. I want to do a little bit of drill down, and I'd like to turn around and say, I want to know what was not blocked. I'd also, so we can click and apply that, and I get a nice list of what was not blocked across my organization. I also might want to turn around and say, well, what I'm interested in is I want to see what was not blocked for my corporate users. So let's apply that. I get a list of what was actually not blocked for my corporate users. And I can see that I've got an issue with lateral movement and infiltration within my organization. I can drill down a little bit more on this, and I can look at different times and see whether it's improved across my environment. I might want to have a look at, am I doing any detection? So if I wanted to, do some stuff on detection, I could turn around and say, well, was anything prevented? I can provide filters, and now I'm starting to get back no results. This is interesting from the point of view of we can see where we've got issues in our environment, and I'll drill down a little bit further with APT29 to show what happens around there. If I drill down into this information and I look at various information associated with it. I have something here, and this is my hash, and this is the malware that I actually brought into the organization. We want to check whether this happens to be real and live. I can go over here, I can paste it into virus total over here, and I can search virus total, and we can see that we are actually playing with real live Maize ransomware here. It's been de-weaponized, but the reason we have to play with real live stuff is because otherwise your tool or your security tool is not going to detect it. So if you're having various issues, so you might find that you might be using one of the ones down the bottom here, and in which case it's, okay, so these guys aren't picking this up, hence spot the problem that I'm having with the test that I'm actually running. You start understanding where things might be going wrong. So Microsoft worked very well, but one of the guys down the bottom that I'm busy using here either doesn't detect it, couldn't detect it, or it's not part of or within their scope. So it's a third-party independent look at why this happens to be an issue within your organization and why you're getting the results that you happen to be getting.
I can see some questions coming through, by the way. Please do remember, if you have any questions, just type them in the Q&A section. Try not to do it in the chat if you don't mind, if you don't, just for security reasons, but put it into the Q&A function. We will pick those up at the end of the session. Thank you.
So I'm going to do the same thing here for APT29 and look at my whole organization and say, okay, let's look at my whole organization and let's get a map as to what's going on about APT29 and map that into MITRE, because that's one of the things that we wanted to be able to do today. And that happened to be, okay, so let's look at MITRE here and see what's happening. Well, I can see where I've got all the green stuff going on here that how many simulations were blocked, how many were actually logged, okay, and how many simulations were actually run. So in total here, I ran 3,000 different types of simulations. Not blocked across my organization, there was 218 of them, and how much of that information was logged, I got 236. What do I mean by that? Well, if I drill down and I look at detected and I look at security events around that, I can see that I'm getting security events coming out of my FortiGate or Fortinet firewall here, whereby it's seeing the traffic go through. So it's seeing my malware actually go through it. We haven't turned on the blocking on my FortiGate. FortiGate just happens to be detecting, and it's creating alerts in my SOC. So what did my SOC do around this? Well, it depends how I built my SOC. One of the ways that I might want to be looking at my SOC is putting in playbooks for each MITRE technique. If we look at it at the moment, there's about 183 MITRE techniques right the way across Windows, Linux, etc., Mac. And that might be one way I'd like to classify the playbooks I put in my SOC to be able to respond to different threat groups or threat intelligence across my environment. And I can start seeing where we're at here with APT29. I've got some work I needed to do in various parts of my actual organization, both on the protection and the detection side. So I'm seeing all of this. And once I've eventually finished this, it might then be a good time to run maybe a red teaming exercise, which is very, very focused, or maybe, you know, getting a pen test, which is even more laser focused on my organization and doing it that way. So what we're being able to see here is that MITRE is providing us with a universal language to be able to have a conversation with each other, with our red team, with, you know, and be able to have threat intelligence. It provides a neat picture to be able to look at our SOC maturity across our environment and start understanding what this is. Because if I just look at things like Maize Ransomware, well, I can change Maize Ransomware very, very easily and it will be back again. Whereas if I go back to my example about behaviors, that's an entirely different exercise. I'm completely disrupting it. So if I work on my organization, I work on things like, spearfishing. How's my spearfishing working over here? So here we managed to run 673 simulations and only 8 of them were not blocked. But I do have an issue here because I've only logged 4 of them. So while my protection is working, I'm not getting much notification about that. Do I want notification? Probably, okay, but I might want to automate the suppression of that, okay, because I don't want to create an incident in my SOC every time spearfishing happens in my environment. So I'm very much on top of things in the spearfishing side of things, but I have some definite issues, in other areas of my organization around this type of issue with what's going on. So in this case, PowerShells and what's happening with PowerShells. So maybe I need to spend some time and look at how I address PowerShells, the use of or not use of PowerShells within my organization. So that's a very brief overview of being able to use the MITRE ATT&CK framework and the language that it provides me, from threat intelligence to be through to being able to understand my organization and use a language within my team as to where my problems actually are, and have a heat map of where my issues are in my organization and where I should be able to start off and start prioritizing what I want to do, and where I should be addressing the issues first. And if we look at it, and our suggestion on how to do this when you use one of these tools is, it's to a certain extent counterintuitive. A lot of people want to start on the outside. Looking at the external perimeter is a good place to start, but one of the other places that we recommend starting is looking at your crown jewel and working backwards, okay? This has the least, and always will have the least amount of remediation actions associated with it the closer you get to the crown jewel. So try breaking the train there, first of all, rather than the thousands that might exist further towards the actual perimeter. Ronan, it's back to you.
Thank you, Andrea. It's really awesome. So I think we can probably flick over these, but just a quick recap of what we looked at. So within the simulation platform, we saw how we could plan a simulation. We chose the Maize Ransomware as an example of that. Some of these platforms, by the way, have thousands or even tens of thousands of attack methods that include most of my, obviously, just there were some questions we had about how many MITRE TTPs we do actually, or we can simulate. And obviously MITRE, the MITRE ATT&CK knowledge base includes anything and everything that has been observed from various different threat actors. Some of those are physical actions, and some of them relate to hardware and things like that. So what we're talking about here are really the digital aspects. There's no physical interventions that we are doing here. Just to be
I think to answer that question in a nutshell, Ronan, things like, if we look at initial access where it talks about hardware additions, we're not physically able to make a hardware addition. So if it requires a physical intervention, we're not able to do it. If it is physically, or if it is actually possible to do it as a software or a simulation, then it is covered. We cover the whole of the MITRE ATT&CK framework across all operating systems, with the exception of the physical.
And it goes without saying, for those who are concerned, we operate completely within ethical walls as well. So it's there's nothing that is illegal or unethical in what we do either, by the way. And that's obviously not to say that threat actors maybe don't adhere to the same guidelines, but that's the way that we operate. So there are some questions, and I have, however, just lost the question, but I think it was relating to what one participant is actually about to look at APT29 as a threat actor and to use the TTPs observed by that actor to test various EDR solutions, I think the question was. I believe the question was to do with here we are. Sorry, thank you. So when we looked at this, what OS was used in our simulation, and what would happen if you had an unpatched client, like a Windows 7 client, or indeed an 2008 R2 server, or indeed if you have unpatched applications at the browser level, or Adobe or Java, for instance. Does that affect the way these simulations work?
So to answer that, if we look at it, when the simulations or the testing was actually run by MITRE, my understanding is they used the Windows 10 machine that was fully patched to make sure that everybody was on a level footing. What happens if you have an unpatched OS client like Windows 7, Windows 2008 R2? Well, it depends what they're exploiting. If they're exploiting a vulnerability within the operating system, there is a highly good chance, or a very good chance, that your protection, like your endpoint protection, might not see that or might not prevent that happening, in which case you are going to be able to exploit it. So this is a very, very good case of saying, okay, what do I do with things like my Windows 2008 R2 servers that I still have floating around? This is where you have these breach and attack simulation platforms to be able to answer those questions and say, right, it is actually vulnerable to attack from APT29. These are the areas that it is vulnerable. So now I might have a business choice. I might have to close off a port. I might have to put it, an access control list, or behind something, or put some type of prevention mechanism to being able to communicate with that server. So the question now is if I do that, is it successful? So we can test and find out whether it is. So we're running what if scenarios, and we can also find out, did I just cut off access to my business application, or the reason for that being right at this moment in time? So you're able to do and run all those what if scenarios with Windows 7, with 2008 R2, and understand what impact this is going to have within your environment.
I would someone point out, by the way, that in the limited time that we have available today, we very much cherry-picked the scenarios and the topics to discuss. This is a much wider discussion, a much wider topic. So very happy to pick up any discussions with anyone in a completely non-commercial context if you have any questions around this. But we chose two examples today around a specific strain of ransomware and a particular threat actor. However, you could apply this in a much more general sense. So if you wanted to just simply look at all TTPs within the MITRE ATT&CK knowledge base and apply them in a safe simulation, you could do that, or indeed have multiple simulations running in parallel, either for general or specific use cases. So just to make that totally clear for you.
So on our next slide, there is mine and Ronan's email address. Please feel free to send us an email. We'll gladly set up a call with you, and you're welcome to drill down on your specific questions, your specific environments. We're happy to put an NDA in place with you and have a totally, as Ronan said, non-commercial call around MITRE, TTPs, breach and attack simulation, tools available, what would be the best approach for your organization. Whatever you'd like to discuss around this topic, we will gladly help and assist and share what knowledge we have. We don't say that we know everything, and we learn stuff every day, but we're very happy to share what we've got.
So there are no further questions at this time. And just on behalf of Andrew and myself, Ronan, thank you very much for attending today. We hope that it was of value and interest, and we do appreciate that these times are very strange times, and this is a valuable and useful use of your time. Thanks very much, and please get in touch if you'd like any more information. Thank you and goodbye.
Thanks so much, everybody. Bye.